What's going on, everybody? Zane here, back with another video. For this one, we have the valid mountain array problem. Given an array A of integers, return true if and only if it is a valid mountain array. So a mountain array is a length of greater than or equal to 3 and all these parameters here. So to better understand this, let's just take a look at the example here. So considering that this is strictly increasing, reaches a peak, and then strictly decreases, this is a mountain array. Now this one is not, because it increases, then stays constant, then increases, then decreases. So that is not a mountain array. Same with these examples where the input 2, 1 is false automatically because it's less than 3 digits basically. And then for example 2, this one goes up but then stays constant. And then this one goes up and then goes down. So this one will return true. So let's take a look at our code here. We have a class solution with a public function type bool called valid mountain array. We're passing in a vector of type int, and I'm going to call this array just for personal preference. So let's first declare a integer number or an integer variable, and we'll just call this I and set that to 0. And just for the purpose of not having to type this out 1,000 times, I'm just going to declare a value for we'll do size equals array.size. So we have our two integer values here. Now, how are we going to tackle this? Well, what we can do is we can actually conceptualize it like we're walking up the mountain, but then we're getting to our peak, and then we're walking down the mountain. So that's what we're going to be laying out here. So we're going to walk up the mountain at checking the peak, and then we're going to walk down the mountain. And then final logic. So what we can do here to walk up the mountain, we're going to need 2 parameters or 2 instructions. And that's going to be that we can walk up as long as the element that we're at is less than the element in front of it. So meaning we have, let's say, 0 and 3. We can walk up if 0 is less than 3, which it is. So we just walk up and we'll add to our integer. So we just continue walking up as long as the element that we're at is less than the next element. And of course, that the element's index here is within the array's size, because we don't want to go out of bounds. So we can say while, and then in here we'll say something and then do something. Same thing it's going to be for when we walk down. So we can say while something do something. So these are going to be the ways that we walk up and down the mountain. To walk up the mountain, we need to say that while the element that we are at plus 1, so the next element, if that is less than the size of the array, then yes, we can continue. And then we also say end. Now how do we ensure that we can walk up the mountain? Well, it has to be strictly increasing, right? So how do we code that up? We can say end the array at I is less than the next element, I plus 1. And that's why we have I plus 1 here, because we need to ensure that the array at I plus 1 is within bounds. So if that's the case, we just add to our integer I. So next thing we want to do is we are basically going to be going up this mountain, and then when we get to a certain point, we're going to reach our peak. So by traversing this mountain upwards, we've now gotten to a point where array at I is not less than array at I plus 1, meaning we are at our peak while going up the mountain. So now we have to make sure, well, we can't have a peak of the beginning of our array, and we can't have a peak at the end of our array. So we just say if I is equal to 0, or I is equal to, the size minus 1. So this is just saying if the peak is at the first, if the peak is our first number or our last number, then this is not a mountain. so we just return false. Now, we walked up the mountain, we dealt with our peak, and now we need to walk down the mountain. So we can do similar to what we did above. We'll do I+1 to ensure that we have our bounds, and then we'll say end array at I is now just the other way around. Instead of less than, we're going to do greater than because we're going down. Then we'll also add. Alright, so now we walked up, we checked our peak, we walked down, and now our final logic. So what exactly is our I++ accounting for? Or what is our I accounting for? Well, if you take a look at this example here, if this is a correct mount array, so let's just use this example. If our array at I is less than array at I+1, and it's in the range, which we'll always assume it's in the range in this case, but let's just assume this, that if that's the case, we'll keep adding 1. So 1, 2, 3, 4, right? So we got 4 here, and then for this one, we're going to have 1, 2, 3. So that's 7. How many do we have in the entire array? 1, 2, 3, 4, 5, 6, 7, 8. So if we say that if I is equal to the entire size of the array minus 1, that means that this will be a mountain array. Now, you might be like, how can we just jump from I equaling the size of the array minus 1 to true? Well, we accounted for the parameters of the mountain array with this and this. So the I would have only gone up if it was a mountain array while going up, and if it was a mountain going down, or a mountain array going down. So we've dealt with the parameters of the mountain array here. Now we're just checking to make sure that is I equal to the size of our array minus 1, and if it is, then yes, we have a mountain array because we've already dealt with whether or not it's strictly increasing or strictly decreasing. So all we need to do here is return true if I is equal to n minus 1. And we can also do something like if I is equal to n minus 1, return true, or otherwise return false here. We could do that, but a shorter way of doing that is just returning true for these values, for this logic here. Otherwise it will return false. So let's run this code. We got a compiler error. Let's see. That's because I used the wrong variable. We're using size here. Let's run this. Looks like it's accepted. Let's open this up. We got a success. So again, I'm just gonna re-brief. We created an integer value. We created a value for our size. We walked up the mountain, assuming that it's strictly increasing and within our range, add to our I. Then once we're at our peak, since we walked up the mountain, if the peak is at 0 or at the end of the array, then we return false because that can't be a mountain. Then we walk down the mountain using the same range as well as a little bit different of these for the strictly decreasing sequence, and then add to our I. Then the last logic is if I is equal to the size of the array minus 1, then we return true for a mountain array. Anyway, that's it for this one. If you guys have any questions, comments, feedback, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.